Hello, everyone. Can anyone confirm if you're able to hear my voice okay? We'll give a couple of minutes so that everyone can join. Okay, thanks, Biraj. Uh, we'll wait for a couple of minutes. Okay, so we can get started. Hello, everyone. My name is Chakrata Janagam. I work as a container specialist, mainly focused on Kubernetes and then OpenShift. In today's demo, this is our agenda. The first part deals with building microservices, and the second part deals with managing microservices. If you have any questions, feel free to post on the chat. I'll try to answer them while we are discussing. I'll have a chat on the other screen so I can take a look quickly. And in the first part, mainly we'll be focusing on API first design, how we can use OpenAPI specifications to do a API first design, and also look at various ways of containerizing your applications. Primarily, we'll be focusing on three different tools, or more than that. But the first one is OpenAPI specification. Is just a specification for defining APIs. And the second part, we'll take that OpenAPI specification and then generate code automatically for a language of your choice. In this case, I'm going to choose Spring Boot, but it can be a different language as well. Once we generate the source code, we'll containerize using OpenShift tools. I'll discuss various other tools if you are interested in. And once you're done with containerization, we will be deploying that inside Kubernetes or OpenShift. In this case, both are same. And then look at the deployment aspects of these Docker images. And then the fun part will be the traffic control. Once you deploy your applications, how do you control traffic between your different microservices? That's what we're going to take a look. And also we'll get more details on how we can get visibility into your microservices. By visibility, I mean how your request is flowing between your microservices, and also how your microservices are performing. All those good things that you need for day two operations of microservices will be looked into. And the third part in the second session would be the security. So we will see how we can secure a microservice without having to write any code using JOT authentication and then Istio. So that's the high-level agenda. Let's go and take a look at the overview now. All right. So for this demo, I'm going to use a example company called Cool Company, and then we will look at the day-to-day activities in that company, and then see how we can build and deploy microservices. So this Cool store is basically an online store which is microservice-based deployment. This store has two microservices mainly. One is front-end, which is written in, let's say, Angular, and then the backend, which is products API, written in Node.js. And the company wants to create a new microservice called recommendations microservice. That is what you see here. And then for creating and deploying that microservice, let's understand how easy it is to start from a API first design, define your API, generate documentation, generate source code, and then containerize it and then deploy it. Like all these activities we'll cover in this 1 hour session. Okay. So this is how the new microservice would look like. This is your new recommendations microservice on top of the existing store, where users will see a new recommendations from this API. Okay, let's take a look. I'll jump into the directly into the demo. For this, I'm going to use OpenShift. This can be also called as Kubernetes, enterprise-ready Kubernetes. If you have not heard of Kubernetes, a short version of Kubernetes is, think of Kubernetes as your cloud OS. You can combine a multiple number of operating systems into one single operating system from the high level, and then instead of dealing with these single machines or these individual machines, you can just talk to an API, and that will take care of deploying your application onto these any of these machines. Okay, this is an abstraction on top of your existing virtual machines. With that, let's get started with the demo. The store application is running inside this project. So you can see my application is hosted here. So this is how it is looks like. What I want to do is I want to give the recommendations API here. Okay, so let's take a look how we can develop that microservice. I'm running a demo script here, but it is all happening live, so I'm not cheating. So let's take a look how it works. First thing, you're going to see that I have a one node Kubernetes cluster. You can do kubectl get nodes or OC get nodes, both are same. So I'm just doing a kubectl get nodes. That means it will list number of nodes inside my cluster. So there is one node here. You can have 1,000 nodes also. Typically, in production deployments, varies anywhere between 30 to 100 in general. And once you have that, this is my microservice. I already opened it here. And then the API, the new API would give a data something like this. So it will provide a data which has a name and then some images and then price and then all, right? So that will be the format of my new microservice API data. Okay. Once I have that, to create this microservice API specification, I'm going to use a tool called APICurio. And this tool is, if you are familiar with Swagger editor. This is something similar to Swagger editor, where you can go and design your API. But this is much more advanced than Swagger. It has tight integrations with your Git and also a very neat editor. So to create an API, all you need to do is link your account with a GitHub. You can see you can link your account with GitHub or any other Git of your choice. Once you link, you can go and create a new API like this. You can choose from two options: OpenAPI specification 2, which is typically called as Swagger, which is the older version, and then OpenAPI specification 3, which is a newer version. Okay. So you can choose OpenAPI specification here. 3, I'm choosing 3. You can also choose 2. And then I want to give this as recommendations API. Okay. And then hit create API. Once you have that, you can click on edit API and then define all your paths, and then also other definitions for your API. So if you are using Swagger editor like this, you basically define your API something like this. But this is more of a manual way where you need to go and edit each of the section and then be very mindful about those tabs and all, right? This is all YAML magic that you need to create. But in this case, this is all in a visual editor. So you can go and create these APIs in a pretty intuitive manner. So the first section is giving some description. So this would be my recommendations. That you can give a name, and then you can give contact details of whom you need to contact for this API, and then also license. So you can set license. It will show you different kinds of license here. You can choose one of them. And then also you can choose what kind of security you are going to put this microservice on. So all these things you can configure in this visual API. Okay, I'm going to skip others to save some time, but you can go and explore more. Once you have that, you can start creating your API paths and also other definitions for data itself. So for path, you can click on add new. Let's say because this is a recommendations API, you can put a recommendations path here and then click on add. I'm not sure if this spelling is correct, but ignore for now. You can also create different paths, like let's say I want to get a recommendation for a specific user like this. Okay, you can create different paths. And for each path, you can go and create different methods. So let's say this recommendation requires get method, okay, to get all recommendations, okay, like that. And also you can put method and also post method. You can configure all these methods one by one. And then once you configure each method, you can click on that particular get here. And then you can explore more further and then create different activities here. You can say what is your request body looks like, and then what are your query parameters, and then your responses here. So for responses, sometimes you might be using repetitive response objects. In this case, our response objects look something similar to this, right? This is our recommendations sample data. So to provide that as your response, what you can do is you add your response in the definitions here. So this will be my recommendation here. And then I can give also some sample data here. Okay, it's very easy to give a sample data. And this data will be provided when you generate your source code. So you can basically save some time on your initial bootstrapping of your API by providing mocks. So you can click on add. And then in the add response here, you can select what kind of response code it is, let's say 200. And once you do that, you can also give options like, once you have this response, what kind of media type it is, application JSON, and then your actual object. So you can say add an example right here or choose from the other one. So you can do a lot of automatic activities right here. But if you're using plain Swagger editor, you're basically defining these objects in the definition section and then referring these definitions inside your uh, other methods here, which is okay, but looks pretty complex. But in this case, this visual editor will give you more control on what you're doing. Okay, so that's the first part of our API definition here. Uh, so ultimately, what we get is a, a open API specification. That open API specification will be used for doing two things here. One is generation of documentation automatically, because you're defining all these methods and return types and all the necessary details. It is easy to generate your Swagger documentation. Okay. Um, and also the other thing is code generation part that we are going to see next. Okay. If you're wondering what OpenAPI specification is, OpenAPI specification is a standard for defining REST APIs. Okay, it might be gRPC in future. I don't know. I've heard like there are things taking place, but for now it is just for REST APIs. Okay. So once you have that API definition here, you can just go click on here and then publish. So it will go and sit in your GitHub. So you have a very intuitive connection with your Git and then your editor, so that all your work will be saved. You can also share your work with your other co-developers by clicking on collaborate. So you can basically work together, and you can also download that YAML file here. Okay. So in this case, I've already downloaded a YAML file which is already defined. But I think I hope you got the big picture of this APICurio editor, which will help you immensely in defining your APIs itself. Okay. So I have defined my API already. I've downloaded it by clicking on here and then download YAML, which is sitting in my downloads folder. Once I have that OpenAPI uh, specification, all I need to do is generate my source code. Okay, so for generating source code, the tool I'm going to use is called Swagger CodeGen. All you need to do is download that Swagger CodeGen library and then put it in your path. And then once you have that binary here, all you need to do is run this command: Swagger CodeGen generate, and then give the OpenAPI specification file, and then the language in which you want to generate source code. Okay, so source code currently is I'm choosing Spring here, but you can choose Node.js. You can choose a number of other different languages as well. Okay, so this is your full command for generating your source code, and then I'm putting the source code inside this recommendations API folder. The -o option gives you where to put your source code. Okay, so you can ignore these. These are optional, but once the source code is generated, it will be sitting in this folder. Okay. All right. So once you have the source code, let's go and test. I'm going to switch to that namespace. Switch to that folder called recommendations API, which we generated right now. And then I'm going to test it using your typical Maven Spring Boot test. Okay. You can say Maven clean package, which will basically build your application, and then you can run it to test it. Okay, so you can see the Maven build is successful, and then I'm going to run it using Maven Spring Boot run. Okay, it is currently running. And then once it is running, I'm going to show you in the UI. It is running on 8080 host. You can see the documentation is automatically generated. So it is running on 8080. And then you can see documentation for get and post method. Post method is once I've defined it and then downloaded it in the previous editing. So that's why you can see post method and get method here. Okay. Not only that, you can also see if I click on try it out here, it gave me that sample mock data which I've generated, which I've given in the initial API definition. Okay, so this will make developers' jobs easy because they can go and get started on their development using these mocks instead of waiting for the full implementation of this API itself. Okay, so that is a pretty good tool. So once you have the OpenAPI specification, you got two things. One is documentation, and then your code generations for free, right? You didn't spend a lot of time on those. So by code, this means it is only a bare bone skeleton. I'm not saying it is fully implemented code, but at least it will give you a very good starting point, so you can get started with your code development. Okay. All right. And then once you have the source code, the next step is to containerize this application, right? So you have your Spring Boot application. Like I said, this can be Node.js application. This can be any other language as well. But once you have these source code generated, let's take a look how you can use the OpenShift Kubernetes to containerize this application without having to spend a lot of time creating your Docker file and all those activities. Of course, if you know Dockerfile, it is pretty good. You can go and create a Dockerfile and then containerize it. But let's see what other options are there to containerize this application pretty fast. So once I have this application, I'm going to switch back to my demo screen again. So now we will create a new project or namespace called BI Dev. BI Dev means Business Intelligence Dev. Because this is recommendations, let's call it Business Intelligence. And then in this project, I'm going to deploy my recommendations API and then test it on my own. Okay. So for that, I can switch to that project. Once I switch to that project, I can go back again to the folder where I've generated my source code. And then to containerize this whole application, it is as easy as running these two commands. The first command is this one, where you set up a plugin called Maven Fabricate plugin. To set up the plugin, again, it is pretty simple. That is all you need to run, Maven Fabricate plugin latest setup, and then it will add a plugin to your pom.xml file. Okay. You can verify opening that using that pom.xml file. But for now, let's move on and then see how we can containerize this application. To containerize this Spring Boot application which we generated, all you need to do is Maven Fabricate deploy. And then what OpenShift does is it will do a build, generate a jar file, combine it with a Docker image which already has like a Java installed, and then it already has CentOS on it, and then combines this jar file and basically creates an application image out of it. Okay, automatically. So you have not written any Docker file, but you still be able to do containerize your application. So let's go and verify how it looks like in the UI. Okay, I'm going to switch to the BI Dev project and then go to builds, and then see a build is running here. Okay, and if you look at the logs, it has already containerized or Dockerized my application using this generated jar file, and then now it is pushing the image into the internal registry. Okay, so you can see the registry push is complete, and once it is already pushed into registry, you can see it already deployed my application. Okay, so without having you to write any Docker file, you are able to containerize your application, your Spring Boot application, just by using simple two commands, which is used by the Fabricate Maven plugin. Okay. If you want to test your application, it is automatically created route. You can click on the route and then go to the Swagger UI HTML page on that particular application. Okay, the same thing that we have seen on the local host, you can see it here right now. So within few minutes, we are able to generate source code, containerize, and then deploy it onto OpenShift. Okay, so that's the focus of why you want to do all this, is because you want to move fast and develop these applications pretty fast. Okay, so we are able to deploy applications. I will take a short break and take a look at the chat. If someone has any questions, please feel free to post on the chat. I see this will be recorded, so it will be available on YouTube, so you can take a look. Any questions so far on what is OpenAPI specification and also Swagger and then APICurio tools that we have discussed? All right, so let's move on. All right, so I'm able to containerize this application in my dev, and then I'm able to test it. It works very well for me. Now my next job is to promote this application to, let's say, QA. How do I do that? Okay, for typically, if you want to promote your applications that is running in dev to a QA environment in OpenShift or in Kubernetes, you basically create a new project called QA, and then provide your Docker image access to that particular QA namespace. Okay, in OpenShift in OpenShift, you have a tight integrations with Jenkins. In Kubernetes, you have to deploy your own Jenkins and then do all the automation on your own. But let's take a look how it is, how easy it is in OpenShift. Okay, so to create a pipeline to promote your applications from dev to QA, all you need to do is put a Jenkins file in your source code, or you can apply your Jenkins file automatically. Okay, it looks something similar to this. Okay, let me see. There is a question on how to set up OpenShift in local. Yes, there is a lot of documentation. I'll discuss that at the end. Okay, so to move this application to a QA environment, I'm going to create a namespace project called QA here. Okay, and then go to add to project, deploy image, and then go to my namespace where the application got developed. And then the developer says, this is my application recommendations. And then maybe he or she has given some tag to that application. And then you can deploy that application inside your QA namespace. Okay. The only thing that you need to keep in mind is you need to provide permissions to pull the image from your dev namespace to QA namespace. How do you do that? It is simple. You just use OC policy add role to user, and then give a specific role called system image puller for QA on dev. Okay, so this is all you need to run. So if we take this and then I'm going to open another window and then run this command. So the QA will be now able to pull applications from dev. Okay, so let's go and take a look if I'm able to deploy. It says there is one already. I'm going to put a recommendations 2 here. Okay. Now you can see my application got deployed in the QA namespace. Okay, so this is totally independent of dev, and then you can the QA can do their testing in their independent namespace. To create a route in the QA namespace, you can just hit on create route, and then there's a special QA route which QA can test. Okay, so as simple as that to deploy your application and then promote your applications pretty easily. So you can see this is working inside your QA also. Swagger UI. Okay, maybe I'll miss something here, but if you put your application, once the application is up and running, you can go to that Swagger documentation and then look at the documentation for your API. And then let's say you have seeing some issues like this, you can also go and take a look at the logs. So the reason why I'm not seeing that is because it is still booting up. I think it is completely booted up right now. And then if you want to go inside the particular application, deployed application, you can click on terminal. And then you are right now inside your Spring Boot application container. Okay, as easy as that. Now I should be able to get it. Oh, okay. Maybe I'm missing something, but once you have that, you should be able to see Swagger documentation here. So we have seen that in the dev environment. Okay, so this is the promotion part. Maybe sometimes you have some issues during the development time, or maybe QA has reported some issues that you want to debug. So how do you basically debug these applications while in there running inside your your production OpenShift cluster, or maybe your enterprise OpenShift cluster, or maybe on your laptop? Okay, so to do that, it is again pretty simple. Let me go back to this. I've opened the source code in the Visual Studio Code that is right here. Okay, this is my generated source code. This is all in here. Default API is here, so you can see different methods and then objects that I've defined. So to debug this application, all you need to do is click on this Start Debug, select your Java debug mode, and then it will open a launch.json. You can ignore these two. All we need to do is require is this last one, which says port is 5005. Okay, so do this in the launch.json configuration, and once you have that, you need to run one command, which is maven fabricate debug. Okay, so what this does is it will open your container in a debug mode so that your IDE can go and talk to that debugger, and then you can basically your container traffic will be forwarded to the port called 5005 on your local host. So you can basically go and do a remote debugging right from your IDE, which is attached to the 5005 port on your local host. Again, this 5005 port on your local host is forwarded to your container running inside your OpenShift cluster, okay, or your Kubernetes cluster. So as easy as that, you can debug right from your IDE itself. Okay. Okay. And then the next part is, let's say the promotion part, you want to automate using some Jenkins pipeline. We have done that manually, but let's take a look. How you can automate that whole promotion part using a Jenkins file. Okay, so this is how you create a configuration called build configuration. And this build configuration, you need to look at this special area called Jenkins file. So you can define your own stages, like build stage, deploy stage, test, and then promote to QA. So this can be your own stages. Okay. The same activity that we have done manually, we can do it in an automated fashion using this Jenkins file here. Okay. How do you apply this configuration? It's simple. You just do OC apply and then give the pipeline address. So this is my pipeline location. So I can just do OC apply and then give that object, and then it will go and kick off a new Jenkins instance inside your development environment. Okay, so you can see that here a new Jenkins instance is kicked off. Once it is ready, you can go and kick off your pipeline, which will automate your whole process of building your application and then testing it and then promoting it to QA, and all of those. In QA, you can have a similar pipeline to promote it to production. Okay, just as simple as that. So you can see it is now booting up. If you look at the logs, the Jenkins is booting up. Give it a couple of seconds, and then this should be ready for our pipeline. While it is getting ready, let's take a look at the pipeline that we have created. So this is a pipeline that we have created. You can go click on Actions and Edit. You can see all these steps that we have defined. You have defined a build step, deploy step, and then test, and then promote, right? For now, just to keep it simple, we are gonna just do, because we already built and then deployed, we're just gonna do testing and then promote. Okay. So in this testing, it can be very complex testing like integration testing, but just to show it, I have put some message there. So it can be pretty detailed one as well. Okay, let's save that pipeline. And let's see if the Jenkins is ready. Jenkins is ready. So we can go and kick off our pipeline now. Okay, select the pipeline and then click on Start Pipeline. So you can see the build is, the pipeline is now running. Give it a couple of seconds. What it is going to do is Jenkins will kick off a new pod, which will do all the pipeline activity for you. You can define what kind of slave that will be kicked off. Either it is a Maven slave, or it can be Node.js slave. Like, you can define those pretty easily. Okay, how do you do that? If you look at this definition, you have mentioned Maven here. So that means it is going to kick off a Maven slave. Okay. All right. So you can also see in the CLI, if you do OC get pods, it will show you a Maven pod there. Okay. So you can see my pipeline activities for test is completed, and now it is ready for promoting it to QA. If I click on this link for promoting to QA, it will ask for my login. And then now I can promote this application to QA in an automated fashion. Previously, we have done it manually. This time, we are going to do it in an automated fashion. Okay, so you can see it is waiting on for my approval. So first time it takes a couple of seconds to boot up, but from the subsequent time, it would be faster. Okay. Any questions so far? Okay, I hope we are on time. Let's see. Once this is up, we can go and approve it. So it will move to QA. Okay. Sometimes this takes quite a lot of time to get into the Jenkins instance. Okay, now it is up. I can click on this proceed button here. That will move my application to promote my application to QA. Okay, this is just image tagging into the QA. There will be a separate QA pipeline which will take that promoted image and then deploy it into QA itself. Okay, so if I can go here, now I should see a new image inside this BI dev recommendations. So you can see there is a promote to QA instance. So I can deploy that and then test that particular instance. Okay, as simple as that. So you can not only do manual promotions easily, you can do automated promotions also using the native integrations with Jenkins. Okay, so let's assume that it went all the way to production, which is our BI project. I've already deployed it. I'm just gonna scale it up so it is visible there. You can see in the UI now, there is a recommendations a product right now. Okay, so that is coming from the a newer recommendations API. But if I do a refresh continuously on this, you can see sometimes the recommendations comes up and sometimes it won't. You can see that here right now. see that it is it's a random. The reason behind it is because in the store application, we have two instances of our products API. One that talks to the plain old direct products, and then the other one, products newer version, will talk to the recommendations that we deploy, okay, based on this deployment pattern that we have seen. Okay, let me open that. So this is your new products API that is talking to the recommendations and providing you recommendations. And then there is a different version, which is old version, which doesn't give any recommendations. So that's why we are seeing two types of outputs here. Okay. So let's take a let's put this in an automatic refresh pattern. So every 3 seconds it will refresh, and then it will show you that sometimes it gives recommendations and sometimes it won't. Okay. So the next part here is, since we have the new recommendations API, we are not sure. I have one question. Give me 1 second. How do we deploy our DB parts as part of pipeline? So DB parts. So let's say databases mostly you will have some kind of deployment already, right? In your enterprise, you have separate database deployments. I would recommend in production you use those standalone deployments for databases. But let's say for development and testing, you want to put your database inside containers, you can totally do that. To deploy databases, obviously, first time you will select, go to your OpenShift UI, click on Add to Project, and then browse catalog, select your database, okay, and then click on Next, and that will deploy your database here. But as part of the pipeline, let's say your promotion has some database changes as well. How do you do that? There are several ways to promote your database changes. Few of the patterns that I know of is, you basically have these deployment hooks inside. For each deployment, you have a pre hook and then a post hook. So in the post hook of your application, or your pre hook of your application, you can also do things like changing some schemas. So you can put your logic of changing the schema right into the some folder called, let's say, migrations folder, and then invoke that script right from your hook. Okay, so it will go and apply all those migration scripts for your database before actually deploying your application. Okay, so that is one way of doing the database updates as well. That's using the migration schemas. But I think overall it varies between what kind of changes you are doing, whether it is a change that will support your previous versions, or your previous versions will be in problem if you apply those migration schemas. So like, you need to do those database migrations pretty carefully, because it again depends on a lot of factors. Okay, so if you think your database changes will not impact your previous versions of your applications, it is as simple as putting it inside your hooks for deployments, and then going from there. If you think it will affect, then you might need to consider something like blue-green approach, where your applications are deployed in more controlled fashion. Okay. All right. Okay. So moving on, going back to our recommendations API here. So you can see it is switching between your old products and then the newer products API. That is the reason we are seeing two APIs here. But I want to bring this change in a very controlled fashion. Okay, I don't want to send all the traffic to my newer version, or I don't want it to be random either. Okay, so how do you control your traffic? So for this, we are going to use something called as Istio. Istio is basically a service mesh for your microservice. So what it does is it is going to inject a sidecar proxy for your existing application, and then all the traffic is controlled using that sidecar proxy. So if you look at our store application, I've already configured Istio here. So you see your application container here, and then there is a proxy container. So this proxy container is responsible for the ingress and outgress traffic into this container right here. Okay, and then all the configuration on this side, this proxy here will be done from a centralized location called Istio control plane. Okay, so Istio control plane is deployed inside this Istio system already, and all you need to do is supply all your rules, like I want to control traffic from service A to service B using this control plane. Okay, so this is how it looks like. Let me show you in a picture. So if you see here, there's a service A and then service B, and then all the traffic is controlled by this Envoy proxy, and the configuration for this proxy is done by a centralized control plane. Okay, this is my control plane, and then you can put your request of controlling traffic to your control plane here, and then this control plane will go and update all the application containers that are running in your cluster, okay, with the rules that you specified. So what is the advantage with this? The advantages are, there are like a number of advantages with this. Few of them are like you can control how the traffic flows in and out of a microservice. And then also you will get a lot of visibility inside your traffic itself. So you can, since everything is going via this Envoy proxy, it will know when a service A attempted communication with service B, it will know how many of them are successful and how many of them are failed. And also it can see how much time it took from service A to service B. Okay, all those metrics you will get it without you having to write any code at all. Okay, so that's the beauty of this sidecar pattern. Let's take a look how we can use this Istio control plane to control traffic for our deployed recommendations microservice. Okay, so let's say in my case, I don't want to introduce my newer recommendations microservice. I want to still route to my old service itself. To do that, all you need to do is I'm gonna skip that part. You can ignore the build. I've already done it in the UI. If it can get completed, I'm gonna show it in a second. So the rule looks something similar to this. Okay, so the object is called route rule, and then the definition, like whenever the traffic is going to products microservice, let's say the destination is products microservice, always route my traffic to version 1, or just split between different versions, let's say 50% to version 1 and then 50% to version 2. You can do that. Or if you change it as 100 here, it will, and then take out this, everything will be routed to version 1 of your products microservice. Okay, so all those controls you can do from your control plane without having to change any code, without you having to mess with your existing deployments. So you don't need to go and scale down something and then scale up something. All those things can be avoided. Okay, so let's take a look how it is achieved. I'm going to go to the GitHub repo which has that, and then show you there. Go to demos. The rules are here. Okay, let's take a look. So if I want to route all my traffic to just products here, how do I do that? Just copy this entire YAML, and then go to your Openshift, go to the exact namespace where you have your applications deployed, and then click on import YAML, and then create. That's it. Okay. Now, once you have this rule, everything should be routed to only version 1 of your application. Okay, give it a few seconds. Okay, something got messed up. I've seen that bug. Looks like in the newer version of Istio, I have to take the application down and then bring it back so that it will apply the rule. There is some bug in the latest Istio one. Remember, Istio is not production ready yet. It's an upcoming feature. It's really in beta, so this should be okay. So give it a few seconds, and you should be able to see all the traffic is going to version 1 of it. Okay. So the store also I need to redeploy. I'm just bringing down and then bring it back again. Generally, you don't need that, but it looks like there is some issue with that. Okay. Putting my store application here. So you can see the traffic is back. And now you should see only version 1 here, which doesn't show any recommendations. So let it refresh for a few seconds, and you should never see the second version, which will be showing recommendations there. Okay, so you should always see version 1. Okay, see, you're not seeing any traffic from the recommendations at all. Okay, the reason is we have used this Istio route rule to say whenever the traffic is going to products, always route it to version 1 of your application, not the recommendations one. Let's say you want to route it to recommendations only, not the version 1. How do you do that? Again, go back to the project, click on import YAML, and then the second part is the recommendations. I want to copy the right name there, so I'm gonna use the name from here. So I'm going to update this name to, instead of version 1, I'm going to update it to recommendations. So once you apply that, you should see traffic going only to the recommendations to microservice. Okay. Again, there is some issue on the latest version. I need to scale it down and then scale it back up again to show that. Okay, it should be back now. Oh, should be. Okay, I'm gonna scale the products microservice also. Maybe that was the reason. Okay, I've just scaled down and scale up again. So you can see now recommendations is coming up. Okay, the rule we have created such that it will always goes to the recommendations API microservice, not to the old one. Okay, so you're not seeing your first microservice output at all. So without having to change any code, in general, without having to taking down anything, you should be able to control how the traffic is flowing in between your microservice. Okay, and also to give you more visibility, Istio also provides a simple utility called service graph that will show you how the traffic is flowing in between your microservice. So you can see from external, the traffic is going to service microservice, and then from there it is going to products recommendations version, and then products old version, and from the recommendations version it is going to the actual recommendations API. Okay, so this is all generated automatically for you. You have not done any code for getting these visibility, right? It is automatically generated for you. So you will get visibility of which microservice is calling which other microservices without having to without having to write any code there. Okay. So you can see the recommendations API here. All right. So if I increase the time, it will show all those catalog as well. Okay. So as simple as that. So this is just a sample of what Istio can do for the traffic management. You can also do several other things like uh, how you are. You can do several other things like retrying microservices whenever something is not working. You can retry. You can also do things like circuit breaking. You can do many other microservice management activities like throttling a service, put a rate limit. I mean, and then a lot of other day two operations that you typically need for any microservice deployment. Okay, there are a number of features that are listed. I would recommend you to go to this istio.io to see what all it supports, and then you can start digging in more. Okay, so that's the first part of providing visibility and then traffic control. The second part I want to show you is how can you apply authentication and then secure your microservice. Okay. All right. Let me stop this. Maybe I'll go slowly here. Okay. So one other thing I forgot to show is Istio also gives you some metrics, which is right here. If you open the Grafana dashboard that comes along with Istio, it will also show you how much traffic is going between your microservices. This is Istio dashboard. And then you can see the global request volume, and then how many number of 400 responses are there, how many number of 500 responses are there, and then what is your success rate, and for each microservice, how these microservices are behaving. So your products microservice, recommendations microservice, all these microservice statistics you can see, right? Like from store to recommendations, like how are your 200 responses and how many are the 400, 300 responses, like all these metrics, you get it out of the box without you having to write any code. That is because your Istio Envoy proxy is sitting along with your application, and then it is routing the traffic on behalf of you. Okay, so it knows how these traffic is flowing, and it will collect all the metrics and then report it to a centralized system of Istio, and then it can also show it in the UI here. Okay, so any questions on the visibility of Istio, how it works? Put it in the chat. If not, we'll move to the authentication part quickly. We are almost at the end of the hour. Let's see if we can do the authentication also. That is our last part. If you want to stay back, stay back. Otherwise, feel free to drop. But I also want to show how you can put a authentication on top of a existing microservice. Okay, so in this case, our newly created microservice, which is our recommendations microservice, is not having any authentication. Okay, it is able to go and get the details without doing any kind of authentication at all. So we want to secure this microservice using JOT authentication, but without writing any code. How do I do that? So obviously, for any microservice authentication, you need to have some kind of like authentication integrations, like let's say JOT authentication, or you need some kind of API key-based authentication. All those all these methods that you can use. In this case, I'm going to use something called as Keycloak, which is a open source project which provides SSO, like a single sign-on, and then also it can deal with authentication systems like JOT authentication as well. So I've deployed a Keycloak application here. Let's see this. Like this is it's like it is not up yet, or maybe it is up. Okay, it is up. So I can log into my key clock instance here. To set up authentication, first of all, I need to create REM and then also users and then define what kind of token they get. All these things I need to define, right? So that's what I'm going to do. I'm going to create a new REM called Cool Store, which is my uh, application. And then I'm going to create a client. In this case, my client is my store application. Okay. And then I'm going to say any URL is accepted. Okay, let me, it is auto reloading somehow. Okay, so I put a star there, so that means it can redirect to anyone. And then I need to create a role for my user. Let's say I create a role called user. That's the typical user. And then once I have that, I need to create a user. In this case, I'm going to create a, I don't know why it is reloading again and again. Okay. So in this case, I'm going to create a user called demo and then provide some credentials. So in the credentials section, I'm going to say, let's say demo. I don't know why it is reloading. I'll put it as demo and demo here. Okay. Once I create a user, I need to map that user with our client. So add that here. Okay. Once you're done with that, you're ready for integrating your API authentication with this key clock. Okay. The way how I did it is right here. So in the OpenShift demo section of my repo, in the authentication section, authentication folder, there's a spec, authentication spec, and then there's an authentication binding. Okay, the spec looks something like this. So you need to create something called as end user authentication policy spec, and then say who is your issuer. In our case, it is Keycloak is a issuer, and this is my URI where it goes and gets a cert and then validates. So I need to import this inside my store application. So let me switch to my store application and then import YAML JSON. I need to change these. So the namespace is store, which is this one. And the realm is cool store, that is correct. And then something you need to validate is this audience is our store application. Okay, and this is the same thing. So that's all you need. Once you have that, hit create. So this, we have already created a spec, but we haven't finalized on the binding yet. Okay, so let's go and bind this specific spec to one of our microservice. So let's go back one more time. And then let's look at the binding here, authentication binding. Okay, so in this case, let me put it here and then start changing those. So in this case, the end user authentication spec binding will use the specification that we have created and then bind it to a service. Okay. So in this case, we want to bind it to, let's say, a products microservice. Okay. So this name will be products. And then the namespace is store. Same thing. The namespace is store. That's it. Okay. So that's all you need to bind your microservice with the JOT authentication that we have chosen. And then let's go and create. So now, once you create that authentication, you should see an error inside your UI. Okay, so if I do a reload now, you see the products are not loading. That is because we have secured the API with a JOT authentication. If you look at the network call and then try to look at our API call here, it will show that it failed because of required JOT authentication token is missing. Okay, that means you're able to secure your APIs without having to write any code inside your API at all. And then how do you access this API then? You typically get a token from your key clock. You log in into your key clock as a demo user that we have created, and then get a access token from there, and then use that access token and then provide as a header value while making the request. Okay, so when the UI redirects you to for login, it will get a token, and then that token will be embedded in the request so that it will pass through all those layers of authentication. I've already written some sample to how to get the token and then apply how to pass the token as well. It should be here. Second. Okay. 1 second. I can go and try it right away. So let me see. Any questions while I'm getting that exact command? Let me take a look at the chat. Okay. All right. So looks like there are no questions on this. So the way you can get that is there is a sample example provided by this guy. This guy has done the demo actually. So the way you do authentication is like this. So you make a post request to your key clock and then provide demo user and then demo password. This will give you a access token. Okay, so and that access token needs to be embedded in the header like this, the bearer token, and then make a request inside your application. The demo here is not supplying those tokens. We are still working on making that UI to pass that token. Once you pass the token, it will be able to go and get the details. Okay, as simple as that. Sure. So miss few points in key clock, and then you can rewind. Okay, I'm going to rewind that. So the key clock setup is to protect your APIs using a JOT authentication. You can use key clock as your token issuer, and the setups look something like this. So you in the separate project or in the same project, you can deploy key clock. This is a typical key clock deployment. I haven't done any customization. Once you deploy that key clock, log into your key clock environment, into the admin console. And then once you have done that, you need to create a new realm called, let's say, cool store. It can be anything. In this case, I've created a realm called cool store. And then I've created a client called store here. Okay. So this store is what I'm going to refer inside my authentication spec. So I've created this store here, and then created a user, and then of course I've already created a role called user. Okay, so I'm going to put that in the spec here. That is something that looks something like this. Let me share this one. So the specification looks something like this. Auth spec. So in this spec, you need to provide your key clock URL and then your realm that you have created. And then your URI looks something like this. It is simple. You can derive it from here. Okay. Once you have that authentication spec, that means your JWT authentication spec, you can bind it using this authentication spec binding object. Okay. In this binding object, you are going to specify your policy, that is your JWT authentication policy, and then that policy needs to be applied on a service that you have chosen. So if whatever services that you want to apply, you can just use services and then apply those, bind those authentication rules on them. Okay. That's all you need to do for securing your microservice. So you can see once that is done, I'm not able to get any of these products here. So if I go and delete those, then it should show automatically again. Okay. Any questions on the Keycloak side? If I go and delete, I'm still working on this demo. It's a collection of large number of demos. So, but if you have any further questions, if you want to try it on your own, and then if you have any questions, feel free to message me on the Twitter or on the meetup page. I will make sure you'll get your answers. Okay. So once I have deleted that binding, you should be able to see the traffic automatically again. So you can see traffic already. Okay, as simple as that. All right, that's all I have for this demo. If you can try on your own, and then if something is not working, just feel free to message me. And thanks everyone for joining. Have a good day.